Hey guys, hi everyone, good afternoon. And my name is Sanjay Raj. Welcome to my channel and welcome to this live stream, by the way. And in this live stream, we're going to be creating a social media application for beginners. This is using GraphQL and Nodejs. So this is going to be a backend service or backend API that we're going to be building using GraphQL. We're also going to be using Apollo server in order to create the server using GraphQL, and also going to be using Node.js for the backend as usual for just JavaScript. So just to get the basics, we will be implementing functionalities such as user authentication, user authorization. So basically sign up and sign in. Sorry guys, my internet is kind of low. So for sign up, we will be using what is it, bcrypt, in order to encrypt our passwords. So we'll be having sign up and also sign in feature. So we'll do all the encryption, decryption, and also do JWT authentication. And we'd also create a functionality in order to create posts, see all posts, and be authorized in order to see posts, be authorized in order to create posts, also delete posts. You can also invite new people to the platform. So that is only going to be admin functionality. So only an admin can invite a person to the platform. So that is going to be one of the functionalities that we will be implementing. And yeah, those are some of the core features that we'll be implementing. Some features such as what is it, like feature and commenting feature, are very very simple. They are kind of straightforward to what we will be building, because it's stuff that we have to do over and over again. Stuff like creating posts is going to be similar to creating a comment. So that is something. So that's my brother right there, he's studying. So yeah, I guess one person is watching. Let's get started with the project. Let's get started with the setup, installing all the packages, Apollo server, setting up the server, and all those things. It's going to be around half an hour or 40 minutes of a live stream. So let's get started. Let me know if you guys can hear me properly, if the quality is good, and all those kind of stuff. And yeah, guys, pretty much. Let's get started. So I'll show my screen. So I've got my basic Visual Studio Code open. So, and I've created a folder called Studio, which is going to be the platform that we're going to be creating. Is just a name that I gave. Studio, which is going to be the platform that we're going to be creating using GraphQL. We're also going to be using GraphQL Playground in order to set up all those kinds of stuff. Ahmad, this weekend here. Okay, thanks, Ahmad, and welcome to the live stream. Thank you for being in the live stream, man. Okay, so let's install all the package and initialize Apollo client, Apollo server. Sorry. Okay, so I'm open up the terminal and npm install Apollo server. Let's wait until that installs. Oh, sorry. First of all, let's initialize an npm init. Let's initialize npm init. That's done. So now we can install Apollo server. So we're going to be using Apollo server to create all the type definitions, the resolvers, all this kind of stuff, basic stuff. Okay. We're also going to be using MongoDB as our database in order to get the data from database and create the app. Okay. Okay. Apollo server is installed. You can see the node modules are there. So let's create an index.js, which we will be using to create our server there. So index.js is going to have our server. Actually, Ahmad, it's not a full stack application. It's just the backend for now. Um, yeah, it's just the backend for now. But then there will be another live stream or another video which we'll be doing for the front end. We'll be implementing this particular API. We'll host it on Heroku, and then we will be using it on the front end using Apollo client. So this is almost a full stack application, but for now we're just doing the backend for it. So right now you can just follow the backend, and then in around 1 to 2 days we'll be doing the front end as well. Yeah. So okay, const equals require. Then let's import Apollo server so we can initialize the server. Apollo server. So let me put format on save. Should be there. Okay. Okay. So we implemented. Uh, okay, we got a lot of questions. A lot of people here. Can you explain a little bit more about Apollo Server? Actually, Ankit, I am also kind of new to Apollo Server and GraphQL stuff, but then I'll just try to like explain it. Apollo is like basically a company. They're using GraphQL and creating creating kind of packages together with GraphQL. So it makes the process of creating a GraphQL API much more easier. So if you previously see, we have to like do plain GraphQL. The setup process and all those things look way more different than how we do it in Apollo server. So we can like create type definitions resolvers in one file, and then you can use resolvers and type definition. So it's a little bit different. So it would be better if you guys can refer to the documentation. The Apollo server and Apollo client have awesome documentation. That's basically how a lot of people are learning from, where people are learning from, because it's an awesome resource. So would highly recommend you guys get it from there. But then Apollo server, there's nothing much to know about it, but then it's just like add-on to GraphQL when we are using it. It works on top of GraphQL, so it's like Node and Express, but then this is way more different than Node and Express. So when we start doing it, you guys will get it. So Shivam, hi, and Ahmad, yep, thank you. So okay, let's get started. So we'll initialize a server. So will be equal to new Apollo server, and let me know if the quality is better, guys, if you guys can see the screen properly. So new Apollo server, we have initialized the server, and inside of an Apollo server we have to give three things, two main things basically. The third one is optional if you want. One is type definitions and the other one is resolvers. Type definitions is mainly the type of any object that you're going to be using. Say you're going to be implementing user authentication. In that place you need a user, so you need to put the type of the user, the data structure of the user inside of the type definitions. So that is basically how GraphQL works. We have to have type definitions, and inside of that we also can define queries. So basically, if you want to get a user, you have to give a particular name to it, particular name to the query. So get user, which should be the query. It will be inside the type definitions. So you have to run that function, which is basically the query, inside of the resolver. So that is a second option that we have to pass into Apollo server, which will also create, and that will basically go fetch the user from the database and then return it to the front end, return it to the client, basically any front end that you're using. So let's create the type definitions and the resolvers. So it's a type defs.js, and also type dev const type devs. So basically it's an object, and I'll say module dot exports equals type devs. So type devs needs at least one query. It needs at least one query. So that is what we're going to fulfill. Let's say type. Okay. So this is not the way to put type definitions. It's not an object. Resolver, you can make it as an object. So there should be a main GraphQL tag, GQL tag, in order to create a type definition. So it basically takes that and turns it into a format that GraphQL can understand. So let's import that from Apollo server. So basically, you can use Apollo server for basically creating any GraphQL application. GQL, and let's say const type defs will be equal to GQL, and then you put the template literal mark, the symbol, and then you type your type definitions, queries, everything. So let's first say type of query, and the first query that we need is let's say to get all of the posts. So basically we don't have anything set up yet. Let's just put posts. So this is just a start, guys. So we when we actually do it, uh, we will talk more about that. Post, which will return a string. Have query post, which is going to return an array of strings. Let's say an array of strings. Let's format the document. Shift P. Okay, so this is done. Let's go here, type defs. We also need resolvers, which we'll create right now. Once resolvers equals to an object, which will do the resolvers. Control exports equals resolvers. So let's import them right now. Mm, dot slash resolvers. It's going to be same for the type definitions. So yeah, so as we imported it as resolvers, we can put resolvers the same name, and it's gonna kind of say that resolvers is equals to what we imported, which is going to be the same name. So as the server is right now set up, we can listen to the server on a port. So server.listen. We can for now hard code it as 4000. But then when you're hosting it, the hosting service dynamically puts on a port. So we have to account for that once we have, or have all of the stuff set up. So which will return a promise dot then we can destructure the URL from it. So it will return the URL. So basically local host and then 4000. It will return the full URL. With that URL, we can console.log template results. Server is running on, and let's put the URL. Let's say in case the server does not start for some reason, let's say console.log error when starting server, and then let's put the error. So right now, okay, there is an error, I guess. Okay, we don't need these brackets. Right now, everything is kind of set up. We need to set up the command so that we can run this application. So let's install NodeMon, which is going to be a development dependency. So we don't need to do that. npm i -d and NodeMon. NodeMon is basically going to refresh your, kind of restart your server every time you save a file or make changes to the file. Because how Node works is, if you make changes to a file, it does not refresh the. It's not a new app. It's not a new server. You have to uh, come out from the server and then start the server again. Let's install NodeMon as a dev dependency. So when you upload it on Heroku or anything, it does not take that into the package.json. It does not install it as node modules on node modules. Okay, so let's go to package.json. We don't need this test command yet. So let's put a start command. So once we type npm start, it should run this command, nodemon index.js. So basically, it's gonna refresh the index.js, refresh all of the files when there is a change. I mean, refresh all of the files when there's a change, any of the file. Let's say npm start. We should start the server for us. Okay, there's an error here. Let's check. Follow server requires either an existing schema, modules, or type definitions. Okay. Okay, type definitions. It's here. Sports equals type definitions. Maybe it's not like that. Let's clear and test it right now. npm start. Okay, the server is right now running. Let's just put a rocket symbol right there. Okay, Visual Studio Code, it takes some time. So okay, right now let's open up the server. Let's go on localhost 4000. Okay, guys. So as you guys can see, the server is here. So this is basically GraphQL Playground. Basically, a client that GraphQL provides. It's built on top of something called GraphiQL. which is basically a place you can query for anything that you create. So it's basically like a client without like a web page or anything. So if you create a query and you just want to test how it works, you can come over here and then run the query and get the data that you want. It's just like Postman but for GraphQL. Okay, so okay, right now the server is actually running. So let's go to Visual Studio Code and okay, let's get started with all of the MongoDB setup. Let's go to MongoDB. We'll be using MongoDB as our database in order to store all of the user data, all the posts data, and get do all the querying and stuff. So actually, I'll actually set up all of these things because we have to log in and all those stuff. So I'll log in and get back with you guys in a minute. Okay, guys. So I've logged in. Once you have logged in and all those stuff, this is the screen that you guys might see. Let me zoom in. So what you guys have to do first is over here. So in order to create new clusters, you would have to pay for the service, but instead you could create a new project on top of the same cluster. So it will use that particular cluster. So it's a shared tier cluster. So you can use another project in the same cluster. You can click over here, click on new project. So we're going to use another new database for that. Hmm. Okay. Over here, what is the name that we gave? Studio. This Studio Backend. Studio Backend. Give me a minute, guys. Okay, sorry guys, there was some technical stuff. So let's just continue with the MongoDB setup. So Studio Backend is going to be the name of the project that we're going to be creating. Let's click on next. As for the members or permissions, we don't need anything. Project owner, let's create the project. Okay, so let's build a cluster for this particular project. So I click on build a cluster and create a cluster, which is going to be free version. Let it be all of the default stuff, but let's just change the cluster 0, which is going to be the cluster name. Let's say backend. Say studio. Let's just studio. So I click on create cluster. Okay. Should work right now. Okay, it might take some time in order to do this building cluster stuff. So until that, okay, what we can do is, okay, let's just talk about how these type definitions work. Okay, basically what type definitions is, so let's say you are creating a user, or you're using you want to do a sign up functionality. What you would basically do in some typely coded languages such as TypeScript is, first of all, you would define a type for that user. That's basically what you do here as well. You say type user, and then what are the fields that you have to give to that user, and then the type of those fields. So a user would commonly have name, which will be string, and if you put this exclamation mark, it will basically say it's a non-nullable field. You cannot make that field to be null. It cannot be null. Basically, it should be a string, or it should be a length string or something. It cannot be null. So it's a non-nullable string. Even if it's, let's just say it's a number. If I put that, it's a non-nullable number, so you cannot make that field null. You can also have email, which should be string as well. It's also non-nullable, and it will also have a password field. Although you don't show the password, you can just have it there in order to you will be doing queries and mutations. You will be doing those uh, calls to the backend. So you obviously receive the password, which will be stored in the database, which will be obviously encrypted. So you can have it in the field of user. So okay, this is okay. You can create a user type, but two main things is queries and mutations. So query is basically to perform get operations, only to get information, not to post information. So inside of a query you can put stuff like posts, users, and that's going to be basically a query that you can hit from to the GraphQL API and get all of those users back. That is something you have to define in this type definitions. So those are called queries, and that is also a type. You can also use mutations, which will be kind of to do other operations, which is post, put, delete, and the what is it? Get, post, update, and delete. So it's going to be only for the stuff other than get. So get is only for queries. Mutations are for other ones, but you can also do it in queries, but it's most recommended to do it in mutations. The mutation is also a type, so you need to put that in the type definitions and put a field for it. Each field is a mutation, so you need to create a function to resolve that mutation. So that is also going to be called resolvers, which is kind of like a thing where you um, run the function and say GraphQL what you need to return for that. So we'll basically do that, and you guys will understand more about it. So let's say you have to create a query in order to get all of the users. So first step would be to say type query. The query keyword is very important with the capitalized Q, type query, and then you have to get all of the users. Now the naming convention is all up to you, but this is the best convention. So you can put users, which is the query name, and this will return an array of users. So this is basically how we define a query. This is going to be a field inside of the query type, and this is going to be a function that will run once you run that query. Users can also accept parameters like this. So let's say users, so let's say you want to do some filtering, and let's say created at is going to be a parameter that the client is going to pass. Created at, which will be a string, and that is non-nullable. You cannot null that field. So the created at is required. So it won't be required at any time when you're creating a backend application. But just to say, you can put that to be non-nullable as well. So inside of this, when you want to return an array of users, you can also make this non-nullable. So basically, when you're returning an array of users, you don't want that array to be all null values, right? So you can do that as well. Array should be non-nullable. So there should be some value inside of those arrays rather than null values. And also that array itself can't be null. That is basically a convention to write all these types in GraphQL. So this is a basic query. So you define the keyword query. Inside of the field, you write the name of the query and then what it should return. And if there's any parameter, you put that name and then the type of that parameter that you want to accept. And then if it's non-nullable or nullable, you can put those exclamation marks. So this is a query. You can also do a mutation, which is going to be to do post, put, and delete functionalities. But you can also do get here, no problem. But it's mostly highly recommend. Most of the companies, most of the people use mutation for the operations and query for get. So inside of mutation, it's the same thing. Let's say you want to create a user. So this is going to be a field name, create user, and this is obviously going to get params, which is going to be the body of the request. So this does not read with request and response, but I'm just saying in terms of the REST API. So create user, you're gonna get the what is it? Get the body from the params. So let's say input will be a string, and this will return the created user. So in order to create a user, you will take input as a parameter. So you would have to put input and then the object of the body that you have to create. And then user will be the user that you actually created right now instead of the create user mutation, which you created and then you return the user. So let's say in this create user function, you have to return something. The client is requesting for the user, so you can put non-nullable. So the backend, the server which you're creating has to return the user, and the input is also required. It's a must. So you can put the non-nullable field as there as well. Okay, so we can see the cluster is done. So let's basically connect this. I hope you guys got a basic understanding of how types, queries, and mutations in GraphQL work. Let me know if you guys understood that, or if you guys need any more clarification with that. I'm also a beginner on this, so it would be better if you guys can also refer to the documentation. The Apollo client, Apollo server documentation is great. So let's click on connect here, and let's say allow access from anywhere, add IP address. Obviously I would delete this project after it's done, so you guys could create your own project, own clusters. I'll just create Sanjay, and I'll just say a random password, which is going to be test123. I'll just create the database user. So in order to access this, we have to pass it all these params from a env file or any way that you want. You want to collect to application, so you get that. You can copy this particular link, and then you can connect it from there using this. So copy this. So you can click on this or just copy. Let's go here. Let's create a .env, because that's where we want to have all of our secure information like our secret key, private key, or all those kind of stuff. So .env, so is going to be the db underscore url, which is going to be this. So let's say Sanjay is the username, and here it requires the password, which is basically the user password that I put in. So it's test123. Studio is the cluster name, and the database name that I put is also Studio, I guess. Hmm. Let me check. Hmm. DB name should also be Studio. If there's any error, it would send it to us. .env, and also in order to access .env file, so as we have put the db url, you can access it from the index.js. We have set up the Apollo server. So let's go ahead and install .env, so you can get access to the .env files that we are using. So npm install .env, clear it. Let's import .env, env equals require .env. So what we have to do is, after we have created our server, we have to connect to MongoDB. So let's just config.env, so we can use .env across our application. .env.config. We also have to install Mongoose in order to interact with MongoDB. So let's install Mongoose as well. At the end of the live stream or after the live stream, you guys will have the source code on GitHub. I'll share it on the inside of the description, so you guys can check that out. Let's import Mongoose as well. equals require mongoose. So I'll say mongoose.connect, and then we want to pass the DB URL which we put inside of .env. So the way we can access is process.env.db underscore URL, and there are some parameters that we would have to pass, but just for now, let's just connect it and check. So this returns the promise. So let's say dot then. Once it connects to the database, um, let's say mm, successfully connected to the MongoDB. If it doesn't, we want to catch the error. We remove that brackets. We want to catch that error and console.log, and let's say error when connecting to DB, and let's put that error. Right now the Mongo's connection functionality is all done, so let's go ahead, look at our server to see whether it's connected or not. Okay, successfully connected to MongoDB, but then as you guys can see, we got some console logs here as well, warnings to pass some parameters. I'm not sure why we have to, but then it's just to create the resources. So if you need to create a user, you need to pass some parameters that will help you to do so. So inside of Mongoose.connect, after you have passed the DB URL, create an object. It's a use new URL parser, use unified topology true. There's also one more thing that we would have to put, which is use should be use. Okay, these stuff would be okay. Okay, as you guys can see, let's wait until. Okay, as you guys can see, we don't have any console logs right now. Let's just cut the server, get it from first. No. Start. It's gonna run the server and connect it to MongoDB. Okay, right now MongoDB connection, everything is done. The Apollo server setup, everything is done. If you guys have any questions until now, you guys can put it in the chat or in the comments after this live. Okay, so we have created the Apollo server. We are connecting it to MongoDB. Let's just format this. Okay, we have connected to MongoDB, and then we're listening for the server. We have the type definitions and the resolvers. So first step would be to create the sign up and sign in functionality. So let's create a models folder for for Mongoose. So we need user.js. Let's import Mongoose, and let's say const user schema will be equals to new mongoose dot schema, and our user will have basically three main fields, which is going to be name will be string, and email will be string, and password will be string as well. But we can also put it differently. We can have it like this. We can make that an object. We can put type string, but that would be necessary if we have more fields for it, like required field, minimum field, something like that. But we will be using a data validation library, so we wouldn't need this. But in an actual application, you would also have to put this. So let's just have that here. Type string, and required will be true. That will be the same for this as well. Let's make this type of string. Required will be equals to true. The same thing here. Password is also obviously going to be a string, because we will be encrypting and encrypting this, so it wouldn't be a security problem or anything. So user schema is done. So let's export it as a Mongoose model. So let's say user const user with that capital U will be equals to mongoose.model user, and we pass the user schema which we want to turn into a mongoose model. So let's module dot exports equals user. I want to export this as a model, not a schema, as a model of mongoose, but obviously it's a schema in MongoDB. Okay, so as a schema is right now done, we can go. So basically how we want to do this is, okay, let's say you want to test this GraphQL, what is it, GraphQL API. The way you want to do is, would obviously do, is to import the schema, then do the testing, which is not the efficient way to do it. You could also do that way, but a way better way is to pass it down through context in Apollo server. So you can just pass the objects, you can mock the object that you're mock the context that you're passing through the object, and then you can perform the testing easily rather than importing it. So once we do it, you guys will obviously understand. Let's go to, so inside of model, let's create an index.js. So inside of this, we will import all the models and export them, so that we have a one-stop place where we can import everything. Let's say user, import it for us, module.exports equals user. So once we have stuff like posts, we will also export it here, so it will be post. So it will be one stop place where you can import the index and then pass it there. This will be here. Inside of this index, there's one property that you can pass to Apollo server called context, which is going to be a function. Sorry guys. Context, which is which is obviously like React context or anything, but in Apollo server, it passes the context object, for all of the resolvers. So if we are creating a resolver in order to create a user, anything we pass inside of the context object will be passed to that resolver as well. So if stuff like JWT authentication, passing down the headers, all those stuff is very easy through the context. So that is what we're going to be doing here. We're going to be passing the models that we're creating to the resolvers through context. So when you're testing the API, it's way more easier. We'll also try to do some testing in this video as well. Let's see if it takes too much time, we might have to do testing in another video. But let's import the models and then export it here. Model, okay, import, okay, const models equals require, okay, dot slash model slash index, and let's return models here which we imported. So it will be an object where we can access the models. We will also pass down the context, pass down the headers, which is the authorization header, through the context. So we can perform authorization and all the stuff. Return the models, we can access it through the resolvers. So it will be way more easier. So let's just remove these type definitions and then create stuff new, because we have created a new model. So we need a user first. Let's create a type of user. Name will be a string that is non-nullable. We have to pass in the name. Is that what it means? That's what it means. So name, we also need the email field, which is non-nullable, and we also need a password field, which is also non-nullable. So from the user perspective, we would have to send the password, but from the backend side, which is the backend side, we will encrypt the password, store it in the database, encrypt it. That will be much better. So we have created the user type, which will have the name, email, and the password. So let's create a mutation, because as you guys, if you guys might have noticed, a query, is to get information, not to post information or put information or to delete. It's to get. So we will be using mutation in order to do those functionalities. Let's create a type mutation. So the naming is really important. So type mutation. Name of the mutation will be to create a user. Any functionality that you're creating, say, let's say you want to create a post, the name should be create post. So let's say create user in this case, and we need an input from the user in order to create a resource in our MongoDB, because obviously we need the body, right? So let's put input, and we can, over here itself we can put an object. We can say we need a name which should be a string, we need an email which should be a string, we need a password which should be a string. So this is very repetitive and it does not look nice in the code because it's a lot, repetitive. The mutation should not be like that, should be in one line or so. So we can have this input as a separate type here. Let's say input, and let's say create user input. So for the inputs that we want to get from the params in the mutation, or from queries for some way you want to use queries, you can put the input keyword and then put the name of the input and then use it over here. So in the input, some things that we need is a name, which is going to be a string, which we do need. So non-nullable. Email is a string, which is non-nullable. Password is a string that is non-nullable. So right now we can use the create user input field as the input, and then the create user mutation will return something. So that should be a user type, which is non-nullable, meaning we have to return the user from the resolver. So as you guys can see, all these types stuff, that is how it is done in GraphQL. So for the input, you have to create a separate type and it will return a new user. So you have to give that model of that user, the data structure of that user, which we defined here. So for each and every model or each and everything that we do, we have to create a type, a mutation, a query in order to do the resolver and then run the function for it. So a mutation of create user, which takes in an input and returns a user. So we have to run this mutation somewhere, which is going to be in the resolvers. So let's have this side by side and do it. So the create user gets the create user input and returns a new user. So the inside const resolvers. Okay, so there are two types of resolvers that we can create. One is field top level resolver, which is going to be an actual resolver. So let's say a mutation here, a field over here, that is going to be a top level resolver. So before anything, those are the mutations, or those are the resolvers that will run first. There are also field level resolvers, which are for specific fields. So let's say for user passwords. So if in case a client does not, in case the front end developer does not know that they should not take the encrypted password to the front end, we can do a field level resolver. We can create a field level resolver for the user type. Then when the password is required, we can return null. So that is a field level resolver. So once we create all those stuff, you guys will understand. So const resolvers, we're going to create a resolver for mutation. The naming should be the same so it can identify. So mutation for create user, which will be a function which mostly accepts 4 arguments, which is going to be the root. There's going to be the previous state. So in case you're using field level resolver, you will get access to the value that is returned in that resolver, and also the user input, which is this. Any arguments, sorry, these are not input, the arguments that is being passed, and then the context. So as I told, from the index.js, whatever we pass inside of the context is going into the resolver. So this is that context. We get access to the models, and also there's something called info. I'm not pretty much sure with it. So there's also something called info. You might not use it most of the time, but it's better to just learn it. So root, arguments, and context. So right now we don't need the root. So let's just put an underscore. We do need the arguments. So let's say args, and then the context, because we have the user model there. So inside of here, we need to validate the data that we're getting before we save. Let's say the name is not there, the email is not there. We cannot save it like that because it's required in the database. So we have to install. Okay. Defined in resolvers but not in schema. Type definitions, create use. Okay, create use, it should be an E. Okay, let's see what the error is. Query root type must be provided. Okay, it needs a query because that is a minimum requirement for GraphQL. Let's just put a sample query like user, which will return a user, which we won't do, but then we'll just have it just for the server to run. Server is running and it's also connected to MongoDB. So we need to install some data validation package. So we'll be using Joy for this. You guys can also use Yup. You guys can use Express Validator. It's all up to you. But you can just use Joy. It's a very lightweight package you can use. So let's validate the input before we get it and then store it in the database. I'll create a folder for validation, and then this is going to be auth validation, because auth in the sense authorization and authentication both. We're going to be using the sign up and sign in validations here. Or else we can just have an index where you just do all the validation. We just have auth validation. JS. So inside of this, we do all the validation. We check if the values are there, and then we return an error. But basically, how Joy does, if there's an error, it just throws a new error. So we get it in the GraphQL playground, which is going to be the client that we're going to be using. So let's import Joy equals require Joy, and then let's create a function for sign up validation. So create user is basically sign up. Sign up. Let's just sign up validation. Let's just sign up. Input is a argument that it takes, which is going to be the input that the user passes. So let's create a data object of how the data should look like. What are the requirements that it needs? So const user schema is equal to joy dot object. Inside of this, we need a name, which should be joy dot string. So it should be a string. Basically, joy dot string means that it should be a string, and it's required, and that's it. You just put those fields, and it returns error based on that. Name should be there. We also need an email, which should be joy dot string. The type of the email should be string, and it should be an email. You cannot just put joy dot email, because an email could be a number or boolean. It should be a string. That's something you have to specify, and it should be required. And we also need password, so it should be joy dot string, and it's also required, and it should be a minimum of 4 characters. So then when we are encrypting and all those stuff, it's more secure. So we have to validate this schema against what we have got. So that's what we will be doing. We'll say user schema dot validate the sign up input. And that's basically going to throw the error if it does see any errors inside of it, if it does get returned any error. So this is going to be an async operation. So let's say async, and let's say await for this result. Once we await it, and if there's a result, if there's error, it will throw the error to the front end. Okay, so exports, and this is done. So we are here, we can run that function. So let's make this an async function as well, and should be an arrow function. And let's await for sign up validation, and let's pass args dot input. So basically, we are passing the input that we got to the sign up validation. It takes it, it validates it against this object. So basically checks if there's an email, name, or password. And if there is an error, if it doesn't match these requirements, let's say the password is 2 characters, it does not match this schema or this data structure, so it throws an error by awaiting. So that's something we did. So let's restructure the input from args, and let's just put input. So this is for data validation, and if it does validate properly, let's just console successfully saved user. Let's just say, because we have not saved it yet, but just let's just say console log. So okay, let's check if the server is running properly. Okay, the server is running properly, and let's go to GraphQL playground right now. Right here, let's make this full screen. Go to playground. Let's cut this. Create a new tab, and we're gonna make a new mutation. So let's say mutation, which is a keyword, and then let's say create user, and we need inputs for it. So it's giving me an error, create user argument input of type is required. So let's put argument field, let's say input, and input will be of specific types. So rather than having it inside of here itself, we'll give variables to it. So the mutation name will be create user, pass the params. So let's define the variable name. Let's say input, which is obviously the input. Create user input is the name of the type that we are using. So as you saw in visuals, in the code that we wrote, create user input is the name of that. So even in the front end, you have to specify that. There are some packages, those developer tools that we can use in order to get this. So this is a variable that we have to access. Input is a parameter that the create user mutation accepts, and it's going to be equal to the variable that we will be passing it. Okay, give me a minute, guys. Okay, so the create user input basically should return a user. So at this point, I guess it will fail because the user, because what we are not returning anything. So let's just return something in the shape of a user. So name will be equal to Sanjay, email will be equal to Sanjay ml.com, password, let's say test123. So this is in the shape of a user. So the types are real essential because we need it in the shape of the user. So we have the name, email, and the password, which is returned. Okay, and also non-nullable. So if I don't return it, it will throw an error. So let's right now open up the brackets and let's take the name, email, and the password. And instead of query variables, as you guys can see, let's remove this. We have to pass in the variables that we specified, pass in the inputs that we need. Let's say input, we need the name, that's okay, email will be test email.com, password, let's just make an error with password is 1, so we should actually get an error. Play, okay, it's not working, so let's check why it isn't. Password, okay, let's just do nothing for an email. Okay, it is working. Well, we should not do that. Let's just console.log what it is doing here. Wait, console.log error, play this, and there is an error. Okay, so let's destructure it from this. Okay, and then let's return the error. Okay, let's say what, return the error. Let's say let's store this in a variable called error, which will be the sign up validation function. So let's wait for it. Okay, so there is an error. So let's do all the functionalities. Maybe it's maybe they changed it or something, I'm not sure. So let's say if there is an error, let's throw a new error with these values, this message. So how we get it is error first argument, no, So it should be error dot details, the first object inside of it, and then the message inside. So that's how we get that. We throw the error if there is any data validation error. Play it. We'll say email is not allowed to be empty. Error dot details dot message. Okay. So let's check if that is the error. Okay. Okay, the error is working. I play. The email is not allowed to be empty. So let's say test. Let's just say test. Should throw an array there. Email must be a valid email. Gmail.com. Password must be at least 4 characters long. So test 123. So we get the password. So this is basically how the validation is doing. So after this, we can save this to our database using the context. We're going to access the context right now. So const user will be, it's a new user will be new context.models.user, and let's pass the input. Let's say new user dot save. Let's wait for that. Let's wait for that. Okay. Couldn't see the code. Okay. So I've zoomed it to the max. This is the maximum I guess I can zoom. If I zoom too much, even I can't see the code. So user will be equals to new user dot save. So that will wait for that operation to run. Once that is done, we want to return the user. But there's one thing that we cannot do. We cannot just save the user like this because the password should be encrypted. So let's do that right now. Okay, now it's good. Okay, so let's install bcrypt, which we'll be using in order to encrypt our password. So let's create a helper function and then return, take the password input and then return the password. Sorry guys. So it's bcrypt, bcrypt. Yeah, it's bcrypt. So okay, let's close this. Let's create a folder for helpers, and let's create one for auth.js, or and let's just create one for, yeah, auth.js. We create a function where we can take the password input and then hash it and return the hash password. So let's say bcrypt equals require bcrypt, and let's export a function which is to hash the password. Let's say hash password, which will take the password input, and const the salt will be equal. So it's going to be async operation. Async await bcrypt dot generate salt. So it needs the number of rounds it needs to generate the salt. Salt is kind of like the hash method or something. So salt, and then the hash password using the salt, bcrypt dot hash. There are two things that we have to pass: the data, which is the plain password that we created, and the rounds salt, which is what we created over here with bcrypt.gensalt. So let's pass the password input and then the salt over here, which will return the hashed password for us. uh, and then let's just return the hash password. Let's go to our resolvers, and right over here we can get the hashed password equals await hash password, which is going to be the function. Let's import the function that we created, hash password, and let's pass input dot password right here, and it will return the hash password for us. And when we're creating a new user, let's spread out the input, and then only for the password, let's pass the hashed password. So it's only going to store the hash password on MongoDB. Over here, the user, okay, it will return everything properly. Let's return the user. Okay, let's check how this is going to work together with all the validation. So right here, we have the create user mutation, which is going to do some data validation, check if there is any error when sending it. And then if it's there, then it sends the error, throws the error, and if and then we hash the password that we get in as an input through this function hash password input using bcrypt. We generate the salt, and then we hash the password through that, and then we create a new user using the context.models, because context.models.user. Why I'm doing that is because inside of the context we are creating an object, and that has a models property in it, and the models property, we go to models property, has a user property in it. So through that I can get access to the user model, and then create a new instance of that user, and then save it, and then return that user. That's basically what is happening. Let's go to GraphQL playground and check whether this works. Okay, uh, let's not put the password. Let's check if that works. Password is not allowed to be empty. Let's say test123 test@gmail.com. I'll put my actual name without any spelling errors. Sanjay. I'll say Sanjay123 @gmail.com, and the password is test123. If you guys can see the screen, I hope you guys can. Okay, so let's play and wait. Okay, so it has actually created the user in MongoDB, and it has sent it for us. So Sanjay is the name, email, and the password is actually encrypted. We can also decrypt it and check the validation. Check whether it works, check whether the password is the same. All those stuff we can do when we are doing the sign-in functionality. Okay, so right now the create user functionality is working. Okay, Konak, for your question, can I get some monitor specs? Actually, this is a 2K monitor with 75 hertz refresh rate. So that's the monitor spec. Also, are you using React for front end? Right now, we are not doing it for the front end. We are just doing it for the back end. We're just doing the GraphQL server using a GraphQL using Apollo server. For the front end, we'll be doing another live stream or another video for that. So just stay subscribed and turn on notifications so that tomorrow or after tomorrow we might do a new live or new like specific video for that. So just stay tuned for that. Yeah. So as the sign up functionality is done, let's right now do the sign in functionality. So first of all, anything that you want to do, you have to create the type definition for it, or a mutation or a query. You have to define it somewhere. So that is the type definition. So inside of mutation, create user, let's say sign in, and the input and the shape of the input that we're going to be getting this time is going to be different. We're only going to be getting the email and the password. So what we have to do first is to create an input for that with the input keyword, input sign in input, and that is going to accept email which is non-nullable. So we have to get the email from the user in order to sign them in. If we don't get them, GraphQL itself will send an error. So we need email and password which is non-nullable, which is why I put the exclamation mark. We can use that as the input. Input is not a keyword. I can also put this to be args. I can put this to be something. Input is just a convention I'm using across the application. So we can access this args dot input for everything across the application. So for this sign in input, which is non-nullable, meaning we need to get those fields in that input, right, according to those types. And then sign in, it's going to also return a user, which is the signed in user. Signed in user, and also for sign in, we need to get the token. So that is also a different form of sending out the data. So let's create the output for that as well. We'll type sign in user output. So all the types are on top and the inputs are right below that, and then we have the queries and then the mutation. So that's how we are going to structure our type definitions. So the sign in user input, it's going to have everything that the user has, but just some external field, some additional fields. So it's going to have the name non-nullable, meaning we have to send that in, password string, and then the token, which will also be a string. So we're going to do a JWT authentication and then passing the token right through that. And GraphQL has a really good syntax. I just noticed it. Yeah, it does have. Yep. Okay, so we have defined the sign in user output, name, email, password, and the token. So as we are right now doing this token and all those stuff, we will also be doing some JWT authentication stuff in order to check whether the user is signed in, and then pass the token through the context and all those kind of stuff when we're doing some authorized queries mutations. So right now the sign in is going to take in an input field, input param, in the field of sign in user input form. So it's going to have the email and the password. It's going to return it in the form of sign in user output type, which is basically this name, email, password, and the token. Okay, let's create this sign in resolver because we have defined it here. We need to resolve it. We need to resolve that function. So it's going to be a mutation. Put a comma there and should be sign in. That is also going to be async because we're going to be dealing with MongoDB here as well. First argument root, we don't need that. Other one is args. Other one is a context, and other one info. We don't need that as well. Here as well, we need to do some data validation. So let's go to validation, auth validation, and do that. So let's copy the entire one. It's going to be almost same. Sign in validation. Sign in validation. Okay. It's going to be sign in input. We don't need the name. And it doesn't need to be okay. Info user schema dot validate sign in input, and then we're going to return that error. So I think this is okay. The sign in validation is okay. So here, let's get the input from the args, and then let's do that validation. So it's going to be async operation, as you guys do know. Let's await for sign in validation, and let's pass in the input. Let's store that in an error variable, and let's check if there's an error and throw the message inside of that error. So if there is an error, throw new error. I'm going to pass error dot details, the first object inside of it, and the message inside. So if all of this does pass, then we want to store, we want to hash the, we want to get the token. First of all, we want to check if the password is right, because as the hashed password is only stored in the database, we want to check if the user input does match that password. But even before that, we want to check if that email exists in the database before making the user signing in. So let's say users equals user dot find with the email being input dot email. So let's check if users dot length is equals to 0, then it means that there is no user yet. User yet. So throw new error, saying, let's say, user does not exist. User does not exist. Let's throw that error. And if there is a user, basically this function, this particular section will run. It will check the user model. Okay, so you cannot access the user model like this because we are passing it through the context. So context dot models dot user, because we're passing it through the context in the index file like this. Models dot user dot find email, which has a email property, and it should be equal to the input that the user passes in. So there should be a user with that email. If users dot length is equals to 0, so basically it should return an array of users. But if it's an empty array, it means there is no user. So we just return that error. And if there is a user with that, then we check if the password input matches the we want to decrypt the password and check if it does match, if it matches. So let's do a helper for that. So let's go to helpers, let's go to auth, let's create a new function, exports dot validate password, which also takes in password input. Password input going to be a string, obviously. And bcrypt obviously has a very good function to compare. So we can pass in the password input and the hashed password. So that's something we have to get, hashed password, and then we can compare both of them, and bcrypt will return whether it's true or false. So through that we can do all of our validation. So this is going to be an async operation. let's say let's say const password is valid equals await bcrypt.compare. And as you guys can see, data, which is going to be the plain password, the password input, and then the encrypted password, which is the string, obviously the encrypted string. So let's pass in the password input, and the hashed password is going to return whether it's true or not. So let's return password is valid. So it will return whether it's true or false. So Konak, for your question, the coding practice seems real professional and clear. We can't mind connecting on Discord or LinkedIn. Sure, Konak, my LinkedIn is, let me share the link. And also, I'm not much active on Discord. Actually, I'm not much active on Discord, but my Discord is also not working because there's some problem with the email verification and stuff. So I'll share my LinkedIn profile just in case anyone wants to connect. So this is my LinkedIn profile, so you guys can connect through there. And also, because how we're doing, we're also going to be doing a lot more lives, so make sure you guys can join. And also, if you guys want to connect on Twitter as well, I have it in the description, so you guys can follow me through that as well. But mostly it's going to be Discord, LinkedIn, or Twitter. So that's mostly most of social medias I have. So this is the LinkedIn. I put it in the comments. Connect, you can follow me there. Yep. So here we have a function in order to validate the password using bcrypt. So we can use this function in our resolver and then check if the user input and the hashed password does match. So let's do it over here. So instead of find, we can say find one. Obviously there is only going to be one user with that email, so we can just say find one, because the function that we're going to be running after this it will be useful if we can do find one, because find actually returns an array. We're not sure if there is two emails or just one email, which is a validation we can do in the sign up function, in the sign up resolver. So once you have checked this, we can check if the passwords are valid. So let's say password is valid equals to await from the validate password function that we did. And let's pass, so instead of users, let's say user, because it will only return one user. So instead of dot length, we can check if there is no user, because it's going to be only one user. So if there is no user, if it's null, if it's undefined, we can check. It will pass this check. It will throw a new error. And also, yeah, also here we can run that function. So two arguments that it requires is the password input and the hashed password. So let's say input.password, and the hashed password will be user.password, because as for the database, we are storing it in the hashed way. We have hashed it through bcrypt and then stored it there. So if the password is valid, it will return true or it will return false. So let's just check for if it's false, then we can throw the error. So if the password, if not password is valid, if the password is not valid, then we want to throw new error saying password does not match. So this will basically check if the passwords are true. Password does match with the one that is stored, one that you signed up with. So if all of these functions, all of these validation does pass, then we can generate a token and then return the token together with that user. So let's also create a helper for creating a token. Let's go to auth.js, which is inside of the helpers folder. So in order to generate a token, we need to install a package called JSON Web Tokens, which I'm sure a lot of people do use. Everyone uses a JSON Web Token. Let's install that. Okay, now that's done. Let's import JWT from JSON Web Tokens. JSON Web Token. Let's create a function in order to uh, you know create a token and then return that token. So exports dot generate token, and basically inside of that token we can store some data. So let's say you want to only do some functions based on the user role. So the user role, you cannot always pass it down through the context. You pass only the token down through the context, and then you decrypt that token, and then there is a user object inside of it which you can store, which you can customize. So we are going to store the user information such as the email and the user's role, so we can do all the authorization, authentication functionalities. So let's get the user database, because we're going to store that inside of the JWT. The token will be JWT dot should be dot sign. It's going to create a new token for us. The payload is the object that we want to store inside of the token. So when we decrypt that token, we will get all of that user information back. So we can do all the functionalities such as authorization. So only like admin based functionalities, all those stuff. So let's pass in the user, and the second argument is going to be a secret or private key. So when we decrypt it, you cannot let everyone to decrypt it. You should only kind of let the person with the right private key in order to access it. So let's go to .env and create a new field for private key, and the private key is going to be test. Okay, rather than test, let's create another one, studio, which is going to be the name of the application we're creating. So private key is studio. So when we are decrypting the token as well, we need to pass in the private key so that it will decrypt it. Only the private key, I guess, and the token and the private key, so it will decrypt it. So we can access it through process.env dot private underscore key, and if there's a third value are some options that you can pass. Some of the options are expires in um, expires in. So basically, a JWT should not be valid for more than around, I'm not sure, around 3 to 4 hours. So you can put that value as well. Expires in. You can put 4HR, which is hours. Expires in hours. So, Konak, any opinion on job opportunities for MERN stack developers? I'm aspiring to be one. So actually, I'm not sure. It would be so MERN stack. A lot of people are actually doing MERN stack. So more technology, expanding into more technologies will be much better. Something like GraphQL would also be beneficial. Yeah, you guys can connect with a lot of people on LinkedIn, Danny Thompson, and they help with a lot of job opportunities and job search, job hunt, all those stuff. And also, hi Aditya, thank you for joining the live stream. Yeah, we didn't do a lot of live stream recently. We did miss out on a lot of live streams because we were busy with some work and side projects and stuff. And also, you can use ES6 syntax by adding type module in your. Yeah, actually, just sticking with how I learned it, just to make sure you can get the functionality for now just done. Yeah, that's it. But anyway, thank you for saying that. So I guess the token will be generated with this function. We can return the token, and we will also need to, okay, extension, not format. Not sure why it doesn't format the document. Yeah, that's fine. So, okay, this generates the token. Also, we might have to uh, decrypt the token and get that user data. We will create a helper for that later. Let's go to the resolver and token. Let's say generate token. I think it would have imported it. Okay, you want to pass the user data. Mm, user dot email. Okay, let's just store the user dot email. ID will be equals to user dot underscore ID, and we will get the token generated. And then let's return everything from the user, and then we want to just return the token that we created, because that's the format of data that we are returning. So if we go to type definitions, sign in user output. So the sign in user output has name, email, password, and the token. So the user that we're getting from MongoDB already has the name, email, password. So the token is something newly we generate through this payload, and then we return that as well. Okay, so the token is being generated. Okay, only takes in the user. Okay, so let's actually check if this sign in works. Let's check if the server is running properly. Okay, it's running. It's also connected. Let's create a new tab. Let's create a mutation. Let's say sign in, and then let's create a variable for input, which will be a sign in input, non-nullable. Basically, we have to send that sign in input will be equal to the variable that we created, and we need the name, email, password, and the token that we generate. So this variable does not have the data that we actually do want to send, stuff like the email and the password. So let's open up query variables, open up the object, let's put input, and let's put the email to be test123. um, let's just put a fake email which is not yet in the database. The password test, and let's just run it. Data and hash arguments required. Okay, so it should be here in our resolvers. So I guess this is the problem. Let's just console log if we are getting an error. Okay, we don't have an error. So we're getting the error from somewhere else. Context dot models. Okay, so we should await for this. Await for this. Try now. Okay, user does not exist. So the test123 at gmail.com does not exist. So we have created a user with this email, sanjay123 at gmail.com. Let's copy this. Let's paste it right here. So right now the user does not exist. Error should not come because we already do have this email. Password does not match. Okay, let's check the password that we put test123, and let's put test123 here as well. And return null for user input dot name. Okay, let's check what the error is. Let's console.log the user that we're getting. Basically, I guess that's the problem that we have. User dot user cannot return null for non-nullable fields sign in output dot name. So let's only get the token just to check if we are getting the token. Okay, so we're getting the token. Okay, so we're not getting the name. Let's just put data user and then the token. Let's just console.log because this is a way we are returning it. Okay, so it's in the underscore doc because when we are spreading it, I guess MongoDB has a different way of returning the data. So let's say underscore doc. So right now I guess it will work. So let's get the name. Let's just check if it works for the name. Okay, so it's sending out the name, the email, and password. I think for now it will actually send the password, the hash password, which is not the way we want. So right now the sign up and sign in functionality is done. Let's create a field level resolver so that once we ask for the password, it returns null because we don't want to return. We don't want to get the hashed password because it's easy to compare the password using bcrypt, but then they don't have the private key. But the hacker or anyone gets access to the private key, it will be easier to get access to the password as well. So outside of mutation, let's create a new object called user. Instead of the user, the field that we want to resolve is password. So let's go to index.js or type definitions. Instead of user, this is a field that we can resolve. It's a type. And inside of these fields, we can resolve these fields in order to run a function and return something instead of what we usually return. So user, and then we get the password field, and then we return something else. Return null instead of returning what you would normally return, which is the hashed password. So we're not returning that. Inside of the password, you would actually get access to the user that you're returning from what is from any mutation that you're accessing the password from. So let's go to type definitions. If you're accessing the password from create user, you would actually get the object that you're returning from create user. So we're returning we're also returning the token from sign in. We would get access to that in the user in the password field. So this is a field level resolver. So we don't have a query or mutation for this, but we can access a particular field inside of a type and then change the value that we return. Um, okay, user password. So it's returning null instead of the password. So let's check whether it works. So we are requesting the password. It should return null rather than this hashed password. Let's check. There should be an error. User password should return null. Fresh. Okay, it should basically work. Okay, so it's not coming to this password field. Let's check why. Okay, the sign in does not actually get access to the user, so we are not returning the user in this case. So that's why it does not, it's not, returning null, because we are returning it in the sign in user output type. We're not using the user. So in this case we're using the user type. So if we requested the password for create user, it wouldn't return, send it. So with this is create user. Let's create the user, cannot return null. Okay, so the password is null. So as you guys can see, the password is null. So that's how that will work. So right now let's create functionality of creating posts and seeing all posts and then inviting users. Let's do that pretty quick. And let's create a model for posts. Post.js const mongoose will be equal to require mongoose, and const post schema will be equals new mongoose dot schema, and post will uh, just have a message and then created by field. So let's just do that. So the message will be of type string, and a message is required in order to create a post. Required, and then created by should be of type object id. So basically it should relate to the user model, and it should be connected to that user model, so it should be object id type. Object id, and then a reference, we should give a reference to the model that we're going to be accessing, which is user. So we're going to store the user id of the user. In case we want to populate it, we can use it. Okay, so let's create user and get all users. Let's go to type definitions. Let's create a new type definition for the post will have a message property in it, which will be a string, and created by, which will be also a string. So created by could be a string, or it should be type of password actually. Created by, yeah, it is required because we will use that over here. Okay, so created by will be type of user, so we'll populate that in the resolver. And let's create a mutation here in order to create post. Input, which will just take in a string. Input create post input message of string, which is non-nullable. Create post input, which will return a post type. Okay, so it will return this post type for that. Create, it will take an input create post type, which is just a message, which will be string, and it will return a post, which it will create on MongoDB and then return it over here. For the created by, we will actually take the user that is signed in currently and then put that as the created by. So right now we have to deal with context, with the context in index. So right now in context we don't have anything, but then we could actually get the headers, and then from that headers we can take the token and then pass it down the context. So we'll get access to the person who is currently signed in through the context. So from context we can destructure request, and the const token will be equals to request dot headers dot let's say auth token, and then after models we can also return the token, so we can do all the authorization and stuff. Okay, so now we have access to the token. The way we actually like give the token to GraphQL Playground, which is what we are using as a client, you can go to HTTP headers and then put the auth token inside, so it will get access to the headers. So let's go to resolvers. Give me a minute, guys. Okay, guys. So let's go ahead and create a new resolver for creating a new post. So right here, let's create a create post. That's going to be async function. We don't need the route. We need the arguments, and then we need the context. We don't need access to the info. So Aditya, you can check out Thunder Client, a VS Code extension, and thank me later. Actually, yeah, we did check out Thunder Client, but in GraphQL, it's better if we use GraphQL Playground itself, because that's what they recommend, and it's much more easier to use GraphQL and test GraphQL queries and mutations. So that's what. Thanks for recommending it. So create post. We need to also validate the input here. So it's just very basic validation, just to check if the message exists. Let's go to validation, create a new one for post validation.js. Let's actually copy something from auth validation, paste it here. This is going to be create post validation. It's going to accept post input, and it's only going to take message as an argument, as an input. Okay, so it should be a string, and it is required. We don't need a minimum or maximum. It should be post schema. So how I did it is double click control D, dot validate it against the post input that we are getting, and then we return the error. So that's done. As this is an asynchronous operation, we can destructure the input from the arguments that we're getting, and then get the error. Let's store that in const error. Create post validation, and let's pass in the input, and let's check if there is an error. Let's throw new error, which is going to be error.details, and then the message inside of it. So let's just go ahead and check if that works. Create post message. So input was required. Okay, so mutation, let's create it here, and the variable will be input, and the type of it will be create post input, because that's what we did in our server as well. Input will be equals to the variable that we created, and then let's go to query variables and then put input, and let's actually create the values that we want to send. Message is the only thing that we want to send, and joy is not defined. Okay, once joy equals require joy, message is not allowed to be empty. So this is, as this is required, it's not empty. Okay, so right now as this is working, we can actually go ahead and store it in our database, and we can do function where we can get the user based on the token that we have inside of the context. Sorry guys, I have the problem putting the video. Okay, so we have access to the user ID through the headers when we sign in. So we get access to the ID. So we can populate the user as we have to send it. We can populate the user and return it through this resolver. First of all, let's create a new post. Actually, we should send the post model through the context. So let's do that as well. Let's go to models index, because we have all of our models here, so that we don't need to put it in our context separately. Let's put post here. Or did I export? I'm not sure if I exported it. Yeah, I should create a model for it. Post will be equals to mongoose.model. The name of it will be post, and post schema module dot exports equals post. Right now we have access to the model post model. So let's import post. That's done. Let's export post as well. So we right now have access to post inside of context. Let's go to, where is it, resolvers, and then create a new post from context. New post will be equals new context dot models dot post, because if you go ahead and check in index, we have context, and that is the object of models property. The models property actually is an object in itself and has the models of use and post, so we can access those models that way, and then pass in the input. Okay, we don't need to pass in the input actually. Dot input, which will be the message only. So let's say message will be equal to input dot message. Rather than that, we can just say dot input, and then created by will be equal to the user object ID. So we can say context dot user context dot token. Actually, we should uh, decrypt the JWT and then return the user to the context. So let's go to auth helpers exports dot dot let's just say decrypt token, which takes in the token. Const user will be jwt dot verify, and the token, and the private key process dot env dot private key, and it will return the user for us, basically the payload that we have. Return the user here, and then if we go to index.js, as we get the token from the headers, we can get the user as well from decrypt token and pass the token. We pass the token, we get the payload, then we pass in the user only. So we get access to the email and the password and all those stuff. We go to resolvers, new post. Now I have access to context.user because I've renamed it to user inside of this context object. I can get access to context.user, which will context.user dot it should be underscore ID, or it could be ID because Apollo server does have some support for underscore ID and just ID. So created by is context.user.id. Okay, so here we can return rather than before returning we have to save it. So const post will be equals to await new post dot save, and this as well we should await it. Actually this is not an asynchronous operation, we create an instance of it and then we save it. So right now we can return the post, which will just be the post, meaning the object, the message and the created at, which is going to be only the object ID created by, which will only be the object ID. So let's create a field level resolver for the post, so that once you request for the created by inside of the post type, it will return the entire user. So let's get the post type, and the field is created by, which will actually return us the data that is being returned from create post, or the resolver that accesses that field created by, which returns that post. So you can get user equals post arguments, we don't need it, we need access to the context. So let's say this is going to be an asynchronous operation, because what we want to do is check for the user model. If there is a user, we just want to get that user with the ID that is in the context that we pass through the context. So this is going to be asynchronous operation. Const user will be equals to await context dot models dot user dot find one, with the with the ID being context dot user dot ID, and then we can basically return the user. And when we are returning the user, if we request for the password, it's obviously going to return null, because we do have a field level result for that specifically. And post created by, I'm not sure, you go to type definitions, created by is here. So one request for user needs a name, email, password. It's going to find one with that and return the user. And yeah, I think that would work. Context.user.id. So instead of context.user.id, because you're not always sure if the person who created the post is the person who signed in, so we actually get the post dot created by, because that is going to be the object ID that is already saved in the database. So we are not actually storing the entire user object in the database, we're only storing the object ID. So if we want to get the created by field separately, we will actually get that created by object ID and then query the database for that particular user and then return it. So, okay, let's go to playground, and then, okay, we already have one for create posts. So let's run this. Context creation failed, JWT must be provided. Okay. Okay. There should be an index right here. Okay, so we don't have an auth token, so that's why we have an error. Let's go to decrypt. So let's put this inside of a try catch block. Once user, if it is there, if this does succeed, then return the user. or else just return null. Basically, the decrypt token wouldn't return anything. So we won't have a user inside of it. So let's actually sign in and get a user token. So we have a user token. Let's sign in again. We have the user token. Let's go to create post. Let's go to HTTP headers. Create an object. Name of it is going to be auth token. Let's paste in the token. Okay, sorry. Okay, and we also have query variables here. Let's run it. Message is not will be empty. Test. Let's just say test message. If I run it, okay, it has created the post. We can also get the created by. So this is giving us an error because that itself is an object. So created by is not a string, it's a object type. Give us a minute, guys. Let me charge. So created by is a object type of string of a user type. So we can get the user information through this field. Let's just get the email. Okay, there should be an error. In the type definitions, I need to give a ID for each of it because it does have an ID from MongoDB. Even the post has an ID. So let's do that. So the created by will also have an ID. Create post will also have an ID. Let's run it. As you guys can see, I'm getting all of the information. So when I request for created by, it's not only returning the string, because if I go to MongoDB, if I go to collections, so if I go to posts, I think, yeah, if I go to created by, it only stores the object ID. I cannot get access to the user information through the object ID. I mean, at least the way we store it. So through this field level resolver, we can get access to the ID, email, and the password only when we request for it. Even I can get the name, sanjay123@gmail.com. But this is not based on the token that I have. So let's just say I create another token. I'll sign in through this. I'll give 777. The person who created this post, it is the one with 123 email account. So I'll go to 777. I'll get that token, and if I put that token, it should be the same user ID rather than it being changing according to the headers that we have. I'll paste that in here. So it should return the same value. Okay, it is not returning the same value. Okay, let's go ahead and check why it is. Create post. Okay, so I did make a mistake because it is creating the post based on the token. So this is not get post. I thought it would get post, because through this token only we are getting the person who is creating the post and then returning the value. So I was wrong. So when we do get post, we will get that information. So right now the mutation for create user, sign in, and create post is done. Right now we need a query in order to get all posts. So this is a query, not a mutation. So this is to get all posts, not to create or update or delete posts. So let's name feed, because obviously it's like your post feed, like an Instagram or Twitter. So this will be an array of posts. Inside of an array, you cannot have all null values, and also the array itself cannot be null. So that is that. Okay, guys. So feed will return an array of posts. The array itself cannot be null, and inside of an array, you cannot have null values. So that is basically what I mean by putting this exclamation mark. So let's go ahead and create a new resolver for that. So this is a mutation resolver. Let's create the query on top of it, query resolve on top of it, and the name of the query field that I have, we go to type definitions. Name of it is feed. So I need to give the same name here as well. Feed. This is going to be asynchronous operation, so it's going to be arrow function with async. The first argument is root, which is not what we need. We also don't need arguments. Let's put double underscore, and we do not okay, we do not actually need context as well. So let's not get that. Just put underscores there, and let's take hosts. Okay, it should be an arrow function. Okay, we do need context because we need access to the models. We are we are sending the models as an object inside of the context. So let's say await context dot models dot post dot find. So as you find, it will return an array of all for what is it, all posts, array of all posts. And here I could give an option where the ID is not equal to the person who created the post, but then the user might also want to see the post that he created specifically. So you can return the posts here. So that is basically that query. Give me a minute. Okay, so this is that basic feed. It's an asynchronous operation. It takes in the context mainly, context.models.post.find, and it returns all of that posts. So you can also get the created by of each post, each person who created that post as well, through the client, which is GraphQL Playground, which is what we are using. So let's go ahead and run this feed and check whether this is working. Let's say query and feed, it's throwing us an error because it's an object. It has fields inside of it. We cannot just require for the feed. We need to request the fields that we need inside of that object. So feed is an array of objects. So we array of post type objects. So what we need is message and created by, and let's just get the ID. I think we might have around 3 posts. So we're getting the feed, we're getting all of those, all the each message of each post, and the person who created it, and the ID of that user. So there should be 2 different users because we did create 2 posts with 2 different users signed in. If I run it, so it does work. So this user and this user is different. I think all of the users are the same. Okay, so we have 3 IDs with the same, 3 posts with the same ID. So we go 4E 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 and 0B right here. If I create a new post, if I run this again, you can see there is another post with that unique ID as well. As you guys can see, there are 5 particular posts. That's pretty much it. And there's one last part that we could add, which is authorization, which is using directives, but it's kind of advanced. But let's actually go through it and create basically a directive is like a function that you want to run based on some stuff. So say on this field you want to run on, let's say on, we only want to run this mutation on one particular category, only one when the person is authorized. So you can basically put authorize right here, and you have to create that authorized directive yourself. Have to extend it from what upload client has already created for their directives. So there are some directives that they already have created which will not be using because we don't actually need them. So you can create these directives for yourself, extend their already existing directive, which is a schema directive visitor, and then you create your your authorization or anything that you want, and you have to customize your directive so that it needs to be acceptable on certain parts of the type definition. So some directives you can only access it on fields, or some on types, some on mutations, some on queries, so some, so that there are different directives that you can create. So you can extend them and check how those work. So right now, let's just create two directives, two very basic directives for authorization authentication, just to check if the user is signed in first of all, which is authentication, and then authorization just to perform. Yeah, we don't need authorization for now because we don't have any admin functionalities. Let's just create an authentication directive. Let's get a folder called directives and auth directives.js, and there's one thing called schema. Uh, Schema directive visitor, which should be from Apollo server. So I'll import schema directive visitor. Even before we create anything like a directive, we have to go to type definitions. So type definitions, and we have to create. We have to define that we are going to be creating a directive with this name and on this particular place, which is going to be a field definition in this case. So let's say directive. We're going to create a directive which is going to be called at authenticated. Basically the person is signed in. We're going to use this on a field definition. Basically a field is like over here, you only want to use it right over here or over here, or the each of these stuff are fields. You can think of this stuff as objects and fields inside of objects. And on field definition you can, like, you can put authenticated and run the directive here, but you can't use the authenticated directive here because this is not a field definition, this is a type definition. So this is only for field definition. So create a directive here, this is the name of it. And yeah, so right now we can go to auth directives. You can create a class called authentication directive which extends the directive that Apollo server has. So we want to visit the field definition in particular because that is where we are accessing our directive. As we saw in type definitions, we're only using it on field definitions. So the name of the directive, the keyword which is directive, name of the directive followed by an XML, because that's how the way the directives are I mean done, and on field definition. So that's basically how you would create a directive. Let's say you want to create an authorization directive. Authorization, you would do that. Let's go to auth directives, visit field definition, which will return the field, and we can create a variable for field.resolve, or you can get the default field resolver. Basically means only run the function when the field actually finished resolving, before it resolves. So as it resolves, we want to run this function. That's basically what we are doing. Let's also install GraphQL because we want to install the default GraphQL resolver from GraphQL. We can create resolver because we'll be using this resolver function or this variable in order to pass down the fields that we're getting to the other to the resolver. You can think of this as a middleware. So we are going to be redirecting the field resolver to this particular directive. This is going to run the authorization or any validation, anything. You can also use this for formatting data, so date, something like that. And if it does pass, then it passes the same arguments into the other resolver, or it throws the error. We can say field.resolve default field resolver. It should get imported from GraphQL. Default field resolver, default field resolver, and then when field.resolve, when the field resolves, we want to check if the person has a token. So we don't need the root, which is a root, arguments, context, and info. We want to check if there is a context dot uh, auth token. Okay, give me a minute. Okay, so we want to check if there is a context dot user property. Let's also put this. There's a context dot, if there is no context dot user property, throw new error, user not authenticated. Basically, the user is not signed in. Else, we want to return. We want to just pass all the variables that we have to the other resolver. So this is the middleware. So we want to pass it to the other resolver. All of these functions. So return resolver. We want to pass the root, arguments, the context, and then the info. So right now this directive is done. We will go more. Actually, guys, right now won't be able to go more into directives. So we'll be actually creating part 2 of this particular video of this live stream, and then we'll be extending this to create more directives, have more functionalities and stuff. So exported this authentication directive. I'll go to index.js and we need to initialize this directive. So I'll say schema directives, and we should give the name of the directive that we actually used. It's going to be authenticated. Paste in the name here, and we want to import the directive that we want to run, which is this. So I think it might import it, which is this. And now we can access the authenticated directive on our field definitions. We'll type definition, and let's say we only want to create post if there's a person signed in. I can say authenticated and it will run that function for me. So let's go to the GraphQL playground and remove the HTTP header. Basically, right now there is no auth token. So there should be an error that user is not authenticated. So as you guys can see, it says user not authenticated. But if I have a token, okay, there is an error with the directive probably. So let's say resolver.call. Okay, just check if this works. Just give me a minute, guys. Let me just check what the error is with this. It should work with resolver like this. Root, arguments, context, and then the info. Okay, it should be field.resolve. That's one thing I made, because field.resolve, that is the function that it has, that the field has. Let's go ahead and check it right now. Okay, right now it should work. Okay, it's working. So if I don't have a auth token, it says user not authenticate. So that's the beauty of directives, guys. It's very easy. You just create a directive for it, then you put it on a field definition, and then it just works. So that's pretty much it, guys. The functionalities that we created today is create users, sign in, create posts, and getting all of the feed. So feed of all posts. So this is an awesome functionality, awesome stuff that we did today. So hope you guys enjoyed. Hope you guys actually learned a lot from this tutorial live stream. Let me know if you guys did learn something. If there was any mistake, just let me know, because I'm also a beginner in GraphQL. So would highly recommend if you guys can leave me some thoughts or any tips for me to code. If there's any best practices to do in GraphQL or better projects to do in GraphQL, that's one of the things. So if you guys have any project, any kind of project that you want to see on this series being built, just let me know down in the comments, so that we can create it in the next couple of videos, or like the next videos that we create. So would highly recommend if you guys could do that. And thank you so much for all of you guys for coming for this live stream. A lot of people were there on this live stream: Ahmad, Ankit, Shivran, Aditya, Krishna. So thank you so much for all of you guys for seeing this live stream, sticking on this live stream, and there will be a part 2 for this specific live stream where we'll be implementing delete post, update post, yeah, update, delete, and yeah, update and delete. We'll also be implementing invite feature, so you can invite other users and it will store that you have invited that user and the user can sign in and all those kind of stuff. We will also be having admin features, which is to invite the user and have a directive to only let the person to invite user only, kind of like if the person is an admin. And we will also have directives, custom directives for authorization as well, just to check if the user has the correct role. If the person says if the person says, if the person is right, is like if the person says he's an admin, we want to just verify that the person is an admin, just change the model just to have a role field in it. And also we'll have a date formatting directive as well, and we'll be finishing up the project in our next series. So hope you guys did enjoy. Hope you guys did enjoy. Hope you guys learned a lot from this particular live stream. Thank you so much, guys. Thank you so much for all of you guys for staying. And even after this live stream, if you guys are staying and watching this video, thanks a lot for you guys. Make sure you guys subscribe to the channel, leave a like, leave a comment if you guys have any suggestions. If you like the video, just let me know what other stuff you liked, what other stuff I can improve on. It would really be beneficial if you guys can do that. It would be really helpful. Also, if you guys have any suggestions on any GraphQL projects or any Node.js projects, yeah, mostly GraphQL and Node.js with together MongoDB on the backend and all those kind of stuff, Apollo server, Apollo client, anything related to that, please let me know down in the comments. Would really be beneficial. Thank you so much for watching, guys. See you guys in my next video. See you guys in my next live stream. Make sure you stay tuned for that. Follow me on Twitter, LinkedIn, and Instagram. See you guys in my next video. Peace, guys. Bye bye.